We're going to spend a little bit of time just trying to understand the two parts of the fundamental theorem of calculus. Now, FTC is what we call the fundamental theorem of calculus. Part 1. The first part deals with a particular function, which we name g, and it's defined with the following equation. G of x, that's g as a function of x, is equal to the integral from t equals a to t equals x of f of t dt, where f is a function that's continuous on the x interval between a and x, or I should say a and b, and x varies between a and b. Okay. Now, to understand this definition of g of x, let's investigate each side of the equation separately. The left-hand side, LHS, the left-hand side of g of x, which is actually g of x, what is that? That's a function. It's a function that depends only on the variable x. In other words, if x is chosen, then g of x is evaluated to be a real number. If it's not chosen, it's just a function, an equation with x in it, just a function of x. What about the right-hand side of that equation in the cloud? It's the integral t equals a to x of f of t dt. Now, that also can be either written as considered a real number when x is chosen to be some fixed number between a and b. In other words, you evaluate it for x equals a number between a and b. Or if you don't evaluate it for a particular value of x, it's just a function of x where x varies. Okay, so you see that if you read these two ideas, the left-hand side and the right-hand side, we're saying the same thing. We're explaining that either way you look at it, left side or right side, this is a function of x, and when you plug a value in for x, you actually get a real number. So indeed, they are the same type of entity. And in the case where f is a positive function, we can actually view this g of x as look at it. It's the definite integral. When you plug a value in for x, you get the definite integral of f of t dt. So what it is, as we've seen, it's the area under the graph of f from t equal a to t equal x, where x is somewhere between a and b. So here's a picture. There's the function, y equals f of t. There are the boundaries, a and b. X is a value somewhere between a and b. And then this g of x is the integral from a to x. So it's the area of the curve, beneath the curve f, between a and x.